All right, well, thank you very much. As was mentioned, I'm a solutions architect here at AWS. One of the things that I work on quite often is helping our customers with their big data requirements, and particularly their streaming data requirements. And one of the most popular things that I'm seeing these days in architectures is how can we do it serverlessly? We're discovering that a lot of our customers, they don't see the value any longer in having to host their own fleet of servers to do a lot of big data processing. And so today I'm really excited to talk to you guys about how a few different scenarios about how to build big data applications serverlessly. So serverlessly is a kind of a catchphrase these days, but I think at the end of this session, you'll have a good idea of a few use cases of big data applications and how to build them serverlessly on AWS. So let's take a quick look at the agenda. So over the next 30 to 40 minutes, we're going to cover a few different things. Basically, we're going to talk a little bit about what is serverless real-time data processing. Then we'll take a quick look at the serverless processing of real-time streaming data. And then we'll do a slightly different example. We'll talk about streaming ETL and analytics. These two go hand in hand, but there are some differences in the solutions and a few of the use cases that you might see. And then we'll take a bit of a different tack, and we'll take a look at serverless data processing with distributed computing. So while the first few minutes we'll spend talking about streaming data, we'll spend the last few minutes talking about distributed computing, things like serverless MapReduce. And then finally, we'll do a quick demo on streaming ETL, and I'll jump into the AWS console and show you all a few things around how to do some streaming ETL on AWS. So let's jump right in. What is serverless real-time data processing? And in AWS, one of our main serverless services is AWS Lambda. So before we can get to the answer of what it is, let's talk about a few of the services that you would use to build a serverless data processing architecture. So if you're not familiar with AWS Lambda, I'll quickly go over it. We'll review it at a high level. Basically, you write your code. You bring your own code in one of 4 different languages, either Node.js, Java, Python, or C#. But unlike a traditional environment, whether it's on EC2 or in a data center where you have to deploy and manage the infrastructure to execute that code, with AWS Lambda, there's no need to do that. You just write your code, and then you configure when that code gets executed. So there's a number of different types of events that trigger the code execution, which we'll get into. But essentially, you write your code, you tell us when that code should be executed, and then we'll manage it for you. It's very cost effective as well. The nice thing about AWS Lambda is that we only bill you for every 100 milliseconds of execution of your function. So it can be a very cost effective way to do a serverless architecture in AWS. As I mentioned, there are a number of event sources for Lambda. We're not going to cover all of these today, but if we take a quick look at the slide, we'll see we've got Amazon S3, DynamoDB, Kinesis, and Cognito. All 4 of those different services store data in one way or another, and you can leverage that data as input to your Lambda function. Configuration repositories, so if you are using any of our tools, AWS tools, for building either your code or your stack that you deploy on AWS, you can hook Lambda functions into events from those services, such as code commit or Amazon Cloudwatch. A number of endpoints as well can be configured to use Lambda. So Amazon API Gateway, for example, you can build a RESTful interface, and instead of having to host your own servers behind that API to execute the API requests, you can configure Amazon API Gateway to use a Lambda function for the business logic of your API. And it also integrates well with our event and our messaging services. So Simple Email Service, Amazon SES, and Amazon Simple Notification Service to use Amazon SNS notification service. You can create a subscriber, which is a Lambda function. So when messages get published to SNS, your code can automatically be executed. So that's sort of one of the core building blocks that we'll be using today in our real-time data processing. So what is serverless data real-time processing? Fundamentally, it's no servers to provision or manage to both ingest and process the data. If we take a look at the slide, we see here, we want to capture data in streams. The streams can be a number of different sources. It can be financial data from your business, your application, IoT data. Perhaps you have dozens or hundreds or thousands of sensors in the field, and you want to stream that data. Log data, it's a very common use case. You might have application logs, error logs, Apache access logs, things like that, that you want to stream to be able to do some amount of processing on that data. And then ultimately, the output gets persisted somewhere. And of course, the choices for you to persist that data when you use AWS Lambda are endless. You can create, you can use your own database running on EC2. You can use a relational database service. You can use DynamoDB and store it in S3. So ultimately, because you own the code that goes into the Lambda function, you define where the data resides once it is done processing the data. So if we look at a few of the different real-time event sources, again, there's a few different models for how data flows into AWS Lambda. We have an asynchronous push model and a synchronous push model. I'm going to talk about those two together, the top two, because they work a little bit differently than the stream pull model. And we're going to spend more time today talking about the stream pull model. So just to quickly talk about the first two, Amazon S3 as an example. If I write a file into S3, I can configure a Lambda function to be executed every time a new object gets uploaded into S3. One of the parameters that would get passed to my Lambda function in that scenario is the pointer to the object in S3. So that gives me, as the developer, a pointer to the file that created the event. And now I can, if I wanted to, go pull the file out of S3 in my Lambda function, do some amount of processing, and then continue on with my application. A synchronous push model is a little bit different, but it integrates with Amazon Alexa and AWS IoT. So take the IoT as an example. You can configure a Lambda function to be executed for an MQTT event push. So if you're familiar with MQTT and you put a message to a topic that you've created in your MQTT broker, you can configure the Lambda function to get executed on a particular message type, as an example. And then the model that we're going to talk more about today is the stream pull model. Amazon DynamoDB has DynamoDB streams. Basically, you can access a stream of changes that are being made to the data in your table. Think about it like a streaming transaction log. You can listen to that stream and then make decisions based on the data that you see in that stream. And Amazon Kinesis, which I'm going to get into more detail on here shortly, but Amazon Kinesis as well. So as data gets written to an Amazon Kinesis stream, you can use a Lambda to take data off the stream and do your own custom processing on that streaming data. So if we look at this, as I mentioned, Amazon Kinesis is one of the services that is supported in the streaming model for Lambda real-time data processing. So Amazon Kinesis is a managed service for streaming data ingestion and processing, and comprises primarily, there are three different services. And we're going to talk about all three today in some more detail, but essentially we have Amazon Kinesis Streams, Amazon Kinesis Firehose, and Amazon Kinesis Analytics. And each of these, they have differences, and they're purpose-built for specific use cases, which we'll discuss here shortly. They're all very easy to use, and they all give you the ability to collect real-time data. And when you use Kinesis Analytics, either in conjunction with Streams or Firehose, you can gain real-time insights into that data with basic SQL. So when you process real-time streams, so Lambda plus Kinesis, streaming data gets sent to Amazon Kinesis, and it's stored in shards. I'm going to talk in a bit more detail about what shards are. But you can have multiple Lambda functions processing data from an Amazon Kinesis stream, so you can fan it out. So if you wanted to have two separate applications. Each of them have their own business logic. They can both become subscribers, if you will, to the data that's in that stream and process the data independently from one another. And Lambda can process the data and store it into, like I mentioned earlier, any number of data sources, because you ultimately are the author of the code, and you, after you do your processing, you can write it to Dynamo, S3. It also supports the ability to very easily log events in your Lambda function to Cloudwatch, and you can write it to other services such as Elasticsearch service as well. So a very rich ecosystem when you process the data from Amazon Kinesis with AWS Lambda. So if you were to set up Amazon Kinesis streams, the first thing you would notice when you go into Amazon Kinesis streams to create it is it's asking you for shards. So we're going to take a bit of a tangent here and just quickly talk about streams, Kinesis streams. A stream is made up of shards, as I mentioned. The easiest way to think of a shard is it is a unit of scale for a Kinesis stream. So there are some limits for how much data you can ingest and egress from a particular shard. And based on those limits, you can define how many shards you would need in your stream. So as an example, each shard can ingest 1 megasecond or 1,000 writes per second. So if you know that your data producer, so if you're producing data, perhaps it's some logs, you know across your fleet of servers that you're writing approximately 5,000 messages per second, you would need at least 5 shards in your stream. And so knowing that data in advance, when you create your stream, you would create a 5-shard stream so that it would be able to support the ingestion rate that your application requires. The data, when it's stored in a Kinesis stream, is persisted for, by default, 24 hours, but you can configure that to remain in the stream for 7 days. After that time has expired, the data is removed from Kinesis stream. So it's intended to be a fairly temporary buffer for your data. So you're writing data to the stream. It's going to live there for up to 24 hours or up to 7 days, depending on your configuration. And then your consumer, Lambda in this case, is going to take the data out so that you can process it. One of the best practices that we have for Kinesis streams is determining the initial size or shards to plan for expected maximum demand. And that's in our, if you look at the, in this particular slide, there is a kind of a wizard, a very helpful tool in the console that would help you to determine how many shards you need. So as you increase the number of shards, basically what is circled in that image, if you go from 2 to 3 to 5, it'll tell you below how many reads and how many writes per second you can achieve a particular stream that is sized with that many shards. Now, once your stream is created, the next thing you would want to do then is create a Lambda function. So let's talk a little bit about creating Lambda functions in AWS. So Lambda functions, you have a couple of levers for what you get when you create a Lambda function. Of course, you write the code, but when you deploy it, you have to determine how much RAM, how much memory do you want to have allocated for the execution of that function. And you don't specifically choose CPU, but by increasing the number of megabytes associated with your function, you will get more CPU. So the CPU allocation is proportional to the amount of memory that you choose for your Lambda function. You also have to choose a timeout. So what happens is if your code is a long-running code, let's say your code, you could expect it to run 10 minutes. That's probably not a great use case for Lambda. Lambda has a maximum timeout of 5 minutes. So what you want to make sure of is that when you configure, and we're going to get to this in the subsequent slide, but when you configure your Lambda to Kinesis integration, you're going to get batches of records passed to your Lambda function, and you're going to iterate through them to do your individual processing. So you want to configure the batch size so that your timeout doesn't expire. And then, of course, you have to configure the permissions. You have to give the Lambda function access to your Kinesis stream so that it can read from it. And then retries. We're going to talk a bit more about error handling with Lambda and Kinesis. But with Kinesis, Lambda retries until the data expires. So there's a few important points that we'll make here shortly. But essentially, if your Lambda function fails, it will not move forward in processing the stream. And there are some ways that you can get around that inside of your code. But basically, the thing to recall is that Lambda will not move forward in your stream if it throws an exception. So when the Lambda subsystem calls your function and your function fails, it will continue to retry that batch of records out of the Kinesis stream until the data expires from. And then lastly, and this is a pretty important point, Lambda function code should be written to be stateless. So because Lambda functions are running inside of a container in the AWS infrastructure, and you have no control over the lifetime of that container, it's very important to realize that the container can be removed at any point in time. And so you don't want to have any kind of stateful properties of your function. If you decide that, and we give you some amount of scratch space, there's some temp storage you can use throughout the lifetime of your function. But it's important to realize that that scratch data could go away at any time if the container is removed. So it's very important that when you write code that it's stateless. Don't depend on any local state to persist beyond the length of the lifetime of your function. So now you've got a Lambda function, you have a Kinesis stream, you have to combine them together, and that's configuring the event source. So you basically take your Amazon Kinesis stream and you map it as an event source in Lambda. You have a couple of options that you create when you do this. The batch size, as I mentioned earlier, is important. So what happens is Lambda, the Lambda subsystem, not your individual function, but the Lambda subsystem will pull every 250 milliseconds a shard in your stream looking for new records. When it finds those records, it will pass them to your function to be processed, keeping in mind that you have the option to set the batch size. So when you create a batch size of 100, as we see in this image, if there are 200 unprocessed records in the shard, only 100 of those records will get passed to your Lambda function. And then, of course, on the subsequent call, on the next polling window, the next 100 will get passed. And so this is, it's a bit of a, this is how you can optimize for the amount of time that your function is executing the records that it's pulling off of the Kinesis stream by configuring the batch size. And we can see here in the middle of the screen, we have the effective batch size every 250 milliseconds is calculated as the minimum of either the records available on the stream, the batch size that you have configured, or 6 megs. So in any given call to a Kinesis shard to get records, the one-time maximum that will be returned is 6 megabytes. So whichever one of those is the minimum for a given polling period is what gets passed to your function for processing. And then the last point is the starting position. So when you create an event source of Kinesis for your Lambda function, you tell it whether you want to use trim horizon or latest. Trim horizon basically will go to the oldest record in the shard and start iterating from there. So it'll start passing from the oldest record in the shard, and it'll iterate through to give those to your function for execution. If you set it to latest, then quite obviously it'll start from now. So if I create this event source and I start processing with latest, then any records that are in the stream already will not get passed to my Lambda function, but any new records that do get created and added to my stream will get passed to my function. So how does it work? I think we talked about this in some good detail, but basically it's polling. So Lambda will poll every 250 milliseconds, and like I mentioned, you don't actually see that. Your function is not executing. So the nice part about this is your function only executes when there are records found. So if your stream doesn't have much data or no data in it, the polling will of course continue, but your function will not get executed, and you will not pay for that as well. So you're only going to pay for when your function is invoked. So for a streaming scenario where you have a Kinesis stream with little or no data, you may find that your Lambda function does not get invoked, and that's very inexpensive. So batches are passed for invocation to Lambda through the parameters. So when you write your Lambda function, the input parameter is basically an array of records. You write your own code to iterate through the process. And batches are invoked synchronously through your function. And where that comes into play is in the error handling of your Lambda function. So we're going to get to the error handling in just a moment. But it's important to think about the tuning for throughput as well. So the maximum theoretical throughput of records in a stream would be the number of shards times 2 megs divided by the Lambda function duration. So I'm not going to get into the details on this. The slide deck will be available later, and you can check this out. But it's quite self-explanatory. It's given that a single shard in a stream has a maximum of 2 megs per second egress, and if you have a sufficiently large enough batch size, then your maximum theoretical throughput is as is described there. So factor based on the number of shards, 2 meg per second egress. The effective theoretical throughput, of course, is slightly different. It depends on the batch size, how long it takes your function to execute, of course, the number of shards. And then, as I mentioned earlier, it's important to remember that processing on a Kinesis stream will not move forward if your Lambda function is throwing exceptions. So one of the things that is abstracted from you in this implementation is that the Lambda subsystem is checkpointing where it last left off. So when Lambda goes and pulls records out of a shard, it writes a record locally inside of Lambda that represents the most recently record pulled from the stream. And then it passes a batch of records to your function. If your function fails, it doesn't go back and get any more records. It gives the same batch of records to your function. So it's important and the main reason that we do that is because we don't want to make any assumptions about the ordering requirements for your processing. If you need the records to be processed in the same order in which they were written to a shard in your stream, then we don't want to move forward if your function fails. So what we do is we will never move forward if it fails. However, if you as the developer are okay with moving forward despite a failure scenario, then you can do that in your code by, of course, making sure that you trap all exceptions. You always return success. And in your code, if you have a sufficient try-catch logic, you can always write to Cloudwatch logs as an example and write records that failed. And then you can build an offline process that can come back later and grab the failed records and process them offline. So if you always return success to Lambda, it will always move forward when it's processing data from the stream. So a few common observations. The effective batch size may be less than configured during low throughput. That's pretty self-explanatory, but if we don't have enough data going through, then you probably won't see you have a batch size set to 1,000, but you're only trickling data in perhaps a few every second or a few every minute, then you may not reach that. And it'll, of course, increase during higher throughput. So that goes back to an earlier slide where I discussed how Lambda determines the amount of data that's being pulled out of a shard. If, of course, there are more records in the shard and your batch size is sufficient, then more records will pass to. And the last point that I'd like to make is that too many consumers of your stream may compete with the read limitations. So I didn't explicitly call it out earlier, but a given shard in a stream has 2 megs per second egress, but it also supports only 5 reads per second. And so what can happen if you have a significant number of consumers on the same stream, if they decide, and as I mentioned earlier, 250 millisecond polling window. So in most cases, most functions, when they are invoked, will take longer than 250 milliseconds. So you may decide you're passing in batches of 500, you're doing some iteration and you're writing that data to a database or to S3. In most cases, that's going to take longer than 250 milliseconds. In many cases, it may take 700 or 800 milliseconds. So in that scenario, let's assume your function takes about 800 milliseconds to process. You could get away with 4 concurrent Lambda functions processing data from your Kinesis stream, because 800 milliseconds times 4, that's 3,200 milliseconds. So now you're into less than the 5 reads per second. If you decide that you wanted to have 5 or 10 or more consumers from a stream, there are some other options. We're not going to get into too much detail today, but some other options for that could be to use a single Lambda function to fan out into other Kinesis streams so that you could get a certain amount of parallelism by having more streams, each with fewer Lambda functions as consumers of those streams. But just a point to be aware of that even though we definitely support multiple consumers on a stream, just be aware that there is a 5 reads per second limitation on the shard. And like all of our services, there are lots of metrics you can go look at in Cloudwatch. The one, this is a very heavy slide, I won't go through all the metrics that are called out specifically, but the one that I will mention, because it does pertain to Kinesis stream with Lambda integration, is the iterator age in milliseconds. So essentially, this is going to tell you how old the last data processed records were. So the iterator age, how far behind am I from records that were recently added to my shard? So it gives you some insight into whether or not your process is falling behind the rate at which data is being written. Okay. All right, so the next step we're going to look at, that's serverless stream processing. Now we're going to quickly take a look at streaming ETL. There's a lot of similarities, but we have a few different services that make the extract, transform, and load features very straightforward in AWS. So let's take a look. What is ETL? So I mentioned it's extract, transform, and load. Many of you are probably quite familiar with that concept. It's been around for a long time. In traditional ETL environments, batch-oriented, servers run scheduled jobs. Perhaps you purchased a large software package. A lot of the large vendors today have managed ETL software, maybe using some Apache projects to do it, or maybe you just homegrown your own software. But essentially, you're running batch jobs to take data between different data sources and update maybe a data warehouse. And it can be latent. So some jobs, in my past experience, I've worked in some data warehouse environments where jobs were taking hours to complete. Versus streaming ETL. So what's the difference? Streaming ETL, you process the data as it gets created. The streaming ETL job runs continuously, and it can produce real-time results. So let's get into how we might be able to do that with AWS. The first service we'll look at, Amazon Kinesis Firehose. So Firehose is where streams that I mentioned earlier, you have to write custom code to produce and custom code to consume data off the stream. Firehose gives you the ability to write data to one of 3 different data stores without having to write your own custom code. So it's a managed consumer is the easiest way to think about it. I write my streaming data to Firehose. There's no administration. I just set it up once, and then I write it to either S3, Redshift, or Elasticsearch. And then to transform the data as it's flowing through Firehose, I can use AWS Lambda. So Lambda integrates nicely with Firehose. Essentially what happens is Firehose will buffer data. It'll pass the buffered data to your function. Your function will do whatever you need to do. Maybe you want to transform it from something like a CSV to JSON if you want to ultimately write to Elasticsearch. Or maybe you want to do a little bit of enrichment. Maybe you want to take a state code like WA or TX, and the output you want it to be Washington or Texas. So those kinds of things can be done, some very simple transformations. But because it's a Lambda function, you have a lot of flexibility in what you can do as a part of your transformation. And then the data gets passed back. So your transformed data gets passed back to Firehose, and then Firehose will ultimately persist that data into the destination configured. So if we take a look at this diagram, basically our data source is writing to the Firehose delivery stream. The delivery stream is passing my raw data to a Lambda function for transformation. The Lambda function returns the transformed data to Firehose. And then Firehose, in this case, I've chosen Elasticsearch as my destination. Firehose will write that data to Elasticsearch. And then optionally, I have the ability to persist into S3 my source records, so I can always keep my raw data, the pre-transformed data in S3. Any transformation failures or delivery failures, so if, for example, my data transformation function couldn't successfully transform a record, that will get persisted. Or if Firehose couldn't write for some reason to Elasticsearch, maybe I've misconfigured my Elasticsearch cluster, the data will also get written to S3. And the next streaming ETL example is Amazon Kinesis Analytics. So Kinesis Analytics gives you the ability to use simple SQL to get insights into your data as it's streaming through either Kinesis Streams or Kinesis Firehose. So real-time stream processing of your data before it ever lands in a persistent destination like a database or S3. So it's a three-step process. You basically connect to your streaming source, you write your SQL code, and then you deliver the results. So there's a few different output choices with Kinesis Analytics that we'll get into. So when you connect to your streaming source, as I mentioned, your streaming source can be either Firehose or Streams. You can also bring in some reference data from S3. So very similar to my transformation example with Firehose, if I have some fairly static data and I want to use that in my SQL, I can put that static data in S3 and it'll get loaded into Kinesis Analytics as a table, and then I can use my SQL to join upon it. I can input JSON, CSV, or unstructured text. And then each input, a schema gets created out of it. So we will infer the schema, but we recommend that you edit. So if you have a JSON document coming in, because of course we're going to write SQL, we'll look at that JSON document, we'll create a schema out of it so that you can then write your SQL based on the schema. So your SQL code, it's standard SQL. You usually write one or more SQL statements in your Kinesis Analytics app. There's a couple of minor extensions to the SQL standard to work with streaming data, things like streams, windows, time, but it's a great solution for things like I want to be able to say, how many times has this event occurred in the past 5 minutes? So in a traditional ETL environment, if I wanted to know in a given window how many times something has happened, of course, the data all has to get loaded into my data warehouse. There may be a latency on that, especially if there is like a batch process involved. With something like Kinesis Analytics, I can get the insights into the most recent 5-minute period as soon as that window closes. So it's very flexible. And then just a quick example, as I mentioned, the SQL is very straightforward. So if you take a look at this example, pretty basic. In this example, I've got a number of temperature devices out in the field sending data to my stream containing whatever they have measured, and I'm just going to create a stream that selects the maximum measured temperature and outputs it. So in this case, it's by 15-minute intervals. So essentially, it's going to have one output at the end of that, which is my maximum temperature that I have seen in 15 minutes. It's pretty cool if I wanted to do something like, I always want to have some visibility into my sensors, and I want to be notified if my maximum value goes beyond some predefined threshold. Pretty easy to do with SQL, and of course your output will go downstream and you can take action. And then continuously delivering the results. So we support outputs to Kinesis Streams or Kinesis Firehose, and then of course if you're writing to Firehose, there are 3 different destinations supported by Firehose, which are S3, Redshift, and Elasticsearch. And you can output in JSON, CSV, or variable column with other types. What we see a lot is destinations that aren't supported. So perhaps you wanted, I'll take my example of the high temperature being noticed in a sensor. If I wanted to take that output and I wanted to alert somebody on my, maybe out in the field to take a look at what's going on with that particular sensor with the environment that it's in, and I want to send a text message, what I could do is the output of Kinesis Analytics could go to a Kinesis stream, and then the consumer of that stream could be a Lambda function. The Lambda function would say, oh, I pulled a message off the stream that's a high temperature alert. And then it would use something like Simple Notification Service or other third-party products to send an SMS message to perhaps my field manager, who then can go take a look and see what's going on, what caused the high alarm. So a few different streaming analytics patterns that we're seeing is pre-processing data, some basic analytics, so things like counts and aggregates over time, advanced analytics, so detecting anomalies or event correlation, and then post-processing. That's an example that I just used. So we're seeing a lot of customers start to use Kinesis Analytics for doing these things with the data on the fly that they traditionally either couldn't do because their data was fairly static, or they couldn't get the immediacy of the results because they had to wait for batch processes to complete. So now they can do it in near real time. And then this just shows sort of the big picture. So we've got our on the far left, we have our data generating devices, including apparently a connected scooter. And we have our ingestion step, which is either Firehose or Kinesis streams, and the data resides there very quickly within the milliseconds time frame. Then we have our streaming ETL. So we're either using Lambda with Firehose or Kinesis Analytics with either Firehose or streams. And we're persisting our data to Redshift or S3 or Elasticsearch. And then we can use other tools in the toolbox, such as Athena or Redshift, to do some analysis of the data after it lands. So we can get some insights immediately with streaming ETL using analytics. And in many cases, we still want to write the raw data downstream so we can run some ad hoc reports. So which approach? Before we leave streaming data, I talked about 3 different scenarios and a few different products. And so before we leave this, I wanted to touch briefly on, why would I use one over the other? So this is by no means, there's a lot of different options, obviously, and your use cases are going to be very different. So which one exactly is the right fit for you would, of course, require some deep diving. But at a very high level, if ultimately your data's destination is S3, Redshift, or Amazon Elasticsearch service, and you have some transformations that you want to do on it, or maybe you don't, you just want to persist the raw data, Kinesis Firehose is by far and away the easiest way to get started with that. No servers to manage, very little code to write unless you want to do transformations. If you require stateful processing, such as aggregations over a period of time, so like the example I gave before is, I want to do a count over a 30-minute window. It would be very difficult, not impossible, but difficult to do that with Lambda and streams because of the fact that Lambda is stateless, as I mentioned. So if you wanted to pull data off of a shard in the stream and you wanted to run some aggregation over a 30-minute period, well, because you don't have a dedicated stateful, anywhere to statefully put your data in Lambda, you would have to then create some other data store, something like a DynamoDB table or something like that to do your aggregation. So if that's your scenario, a much better fit for that is Kinesis Analytics. So Kinesis Analytics does give you stateful processing where I can do a windowed aggregation at time. And then persist your data using Kinesis streams with Lambda or to Kinesis Firehose. And if you have stateless processing or you have varied destinations, so ultimately perhaps you want to send this data downstream to, like I mentioned earlier, a simple notification service, you want to forward it to another stream, you want to write it to just your own custom backend, then Kinesis streams with Lambda is the best solution for that. Okay, so let's move away from stream processing and get into serverless data processing with distributed computing. So primarily, we're going to talk about the MapReduce model with serverless processing. So why serverless processing with distributed computing? Many of the same reasons why we see customers beginning to use serverless options, of course, applies in the big data MapReduce world as well. Removes the difficult infrastructure management. If you have a MapReduce cluster, it's a lot of moving parts, the cluster administration. Even with, we have, Amazon does, AWS, we have EMR, Elastic MapReduce, but you're still having servers in your infrastructure to do that. And you still have to be aware of particular tools that are unique to a Hadoop environment. And it also, using a serverless MapReduce model, eliminates the complexity of state management, and I'll get into that with with an example. And it brings distributed computing power to the masses because there's no cluster management. Also eliminates utilization concerns. The way that it scales, because we're ultimately going to be talking about Lambda functions and files in S3, we scale by concurrently invoking additional Lambda functions. So utilization is on the per 100 milliseconds, as I mentioned earlier. It's a very cost-effective option. So your Lambda functions are billed per 100 milliseconds of execution. And it's very easy and automatically scales horizontally by invoking, like I mentioned, additional Lambda functions. So this is the picture of how you can do it. And I will refer to you, if you want to check this out in much more detail, in this deck that you'll get later, there is links to a GitHub repository where we have taken this reference architecture and made it available for you to do. So if you want to run your own serverless MapReduce environment, we have a framework that you can use. But essentially, you write your mapper functions, and of course, it needs to be in a language supported by Lambda, which is Node, Java, .NET, or Python, C# specifically, actually. And you write your reducer functions. So pretty straightforward. And then you create a configuration. So you make sure that your data, if you look at the top left, kind of where it says step 1, and we have the input bucket, all your raw data files get loaded into a bucket in S3, and you tell us where that resides in the configuration file. And then you use, there's a Python driver script that you execute from any environment. It's not doing any of the data processing. It's just the driver, and it kicks off the job, and that's pretty much all it has to do. So it can run from just about any environment. But ultimately, what happens is your mapper functions get invoked using your source data. As your mapper functions complete and write their output, we use the S3 to Lambda event integration. So now my mapper output triggers another function that invokes the coordinator, which is a function that we have written. The coordinator then maintains state. It's using another file in S3 to main state, so it knows how many mappers were needed and how many have been completed. And when all the mapping jobs have been completed, it will then recursively create your reducers. So now your reducer functions get executed to reduce down your data based on whatever you've done inside your code. And then the last step, of course, is the final reduction, and it'll output that into another result location in S3. So all of this has happened without the need of any additional servers, no Hadoop cluster to manage. I basically write my raw data in files in S3. I've configured I've written, of course, my mapper and reducer functions, and I've configured this, and I just kick it off. It's fantastic, and it scales very wide. I definitely recommend it, and check the links out at the bottom of the deck if you want to get to the reference architecture. And then I'll make one quick note. There's another project out there called Pyren that scales extremely wide. So basically, it gives you, if you're a Python developer, the ability to take your Python functions that you may be using for big data processing today and map them to Lambda and scale very, very wide. So I won't get into too many details on this particular slide, but the PhD student at Berkeley, he created this and has made it available, and he's done some benchmarking, and you can see in the bottom left upwards of 40 teraflops of performance across about 2,800 simultaneous functions that he's invoked. So very powerful. You can scale really, really wide when you're using Lambda. I will point out, by default, AWS accounts have a 1,000 concurrent invoke limit, but that is a soft limit. And so if you wanted to create a scenario similar to what we have done here with Pyren, and you needed to have 2,800 or 3,000 simultaneous invocations, pretty simple. Just go to our support page and create a request to increase the number of simultaneous invocations allowed for your account. We'll get some information from you, and you can then get to this level of scale as well. So if I go back to the MapReduce function reference architecture, we did do some benchmarking. There's a popular benchmark from AmpLabs that we ran by using the data set, which is essentially a number of HTTP logs. Basically, it's page visits, and had 90 million rows. And what we did is we ran the MapReduce job using Lambda and S3 that I described earlier, and we compared it against some other common technologies. And so this is the result set that we see. So if we look at the second row on this, we can see the serverless MapReduce job, and we see the number of seconds that it took for each of the steps, the scans that we were running. So as you can see, obviously it's not the fastest, and we don't expect it to be the fastest. Many of these other tools that we see here are dedicated for this. However, the nice thing about it is that it's certainly acceptable. It's not the slowest, and also there was no server to manage. So it was a very good example of using serverless MapReduce. Okay, I'm going to quickly do a demo of streaming ETL. This is what we're going to build. Very simple. I've got most of it built. I'm just going to walk through a few of the components in this. But imagine we've got an e-commerce website and it's sending order events. We've got a Kinesis Firehose receiving all of the order events. And then what we want to do is persist all those to Redshift for long-term storage and BI reports. But we also want to get some real-time insights. We want to see what are the top items being ordered right now so that I can feed that to a dashboard so that my business intelligence team can get some insights into what's moving right now on the website. Okay, so I'll show that in demo really quickly. So the first thing I'm going to do is send data to I'm already sending data. Okay, so there's a tool that we have created in open source. The link is available again in the references section, but it's called the Amazon Kinesis Data Generator. Just want to call this out because if you want to practice or get some testing done with streaming data, you don't have your own streaming data source, or even if you do, but you just want to mimic what you see in test and production, you can use the streaming data generator to do that. So I will log into the streaming data generator. And you choose the region where your stream or Firehose resides, and we're going to do webinar demo Firehose. I'm going to send 5 records per second, and we'll take a quick look at the order. So this is JSON record, customer ID, order date, and then there's a lot of flexibility in how you can create a record template, but for this particular example, I'm going to just pick a random SKU. So these are just some random SKUs that represent products that I'm selling, and then a quantity. And then I'm going to send that 5 records per second to my Firehose. Okay? So now this is being sent to the Firehose. I go into Firehose console. So if you're not familiar with Firehose console, it's under the Kinesis services. Click on Firehose, and you'll get a list of Firehoses that you have created, Firehose delivery streams. I've created one. My destination, if you recall from the diagram, is Redshift. So we're going to go in here. We can see I've got S3 configured as well. So I didn't get into too many details, but when you choose Redshift as your destination with Firehose, it first writes the data to S3, and then it does a Redshift copy command, and it moves the data out of S3 into Redshift. So, and my Redshift cluster is right here called Webinar Cluster. I'll take a quick look at that in a moment. But let's just do some monitoring. So this was running while we were talking, but we can see the number of records. So I can see I've got quite a few records being written to Redshift. These are the number of bytes, number of records being written to Redshift, and then I see 100% delivery success to S3. So I would recommend, when you get started with streaming data, the monitoring tab is a very useful tab to just get a quick glance at your streaming ingestion architecture. You can see what's working, or if it's not, you can see that as well. So that's a quick overview of Firehose. Now Firehose is delivering our results to Redshift. So I've got a SQL workbench opened here. And the nice thing about this solution, as I mentioned, Redshift, I want all my data in there. Right? I want to stream all my order data. So Redshift is just any Postgres compatible client will work. I can execute a query, and now I can see I've got data flowing into mine. It's probably hard to see on your end, but here's some records. We've got my customer ID, order date. And now I've got all my data streaming, but streaming straight into my Redshift cluster. And then in parallel, if you recall my diagram, I had Kinesis Analytics because I wanted to get some insights into what is selling right now. So I can switch over to Analytics. I'll look at my analytics application that I've created in advance called Serverless Webinar Demo. Go look at the details. And the thing that we'll just point out really quickly is how basic the SQL is. We have some built-in functions, top K items tumbling, that's going to tell me what are the top items in this case, in this particular stream of data. So I'm looking at the SKU value that was passed in. I want to find out the top 5. I think my definition, my requirements said 15-minute windows, which would probably make sense in the real world, but for a demo, we want a shorter window. So we're going to go with a 30-second tumbling window, and then top 5 items being sold. And so these are the results. And so this is streaming right now. The data that I'm sending from here, the data generator, is being analyzed in real time by my Kinesis Analytics application. And if I scroll to the right, there we go. I get, I'm sorry, that's the input data. So what we just looked at there was the actual raw data. What we want to look at is the results. So here are my real-time analytics. So I have this SKU sold 11 times. And if we let this go till the end of the 30-second window, we'll see another batch of records. I'm going to get the top 5 and how many of them were sold. So we'll just give this a second. This should pop up and show us the SKU and the number of times that it was purchased. It takes a few seconds for this. Because it is a 30-second window, there are no outputs until the end of the window. And so here we go. Now we have the SKUs being sold. The row time represents the time that Kinesis Analytics processed the data. We have SKU and then how many of them were sold. And so I'm not going to go through and show how this flows downstream, but you can imagine it's pretty straightforward now. This data would get written to a stream that could get picked up by Lambda and write it into a database that would drive my real-time dashboard. So now it's pretty simple. I could have a dashboard. A business intelligence team could use that to get some insights into what's selling. So that concludes the demo. We're going to just quickly go back to the slides, and then we'll do some Q&A. All right, so that concludes the presentation. I think we have some time for Q&A. I do recommend when you get your hands on these slides that you take a look at some of the next steps. We have all the links available to you that I referenced today. So thank you very much. I do appreciate you spending your time with us today to learn about building big data applications with serverless architectures. So now we'll take a few questions.